Good morning, students. We are studying NCERT Class 8 Math Part 1, Chapter number 5, Numbers Play. Today is 23rd August 2026. We have completed 4 chapters of this book. If you want to learn those chapters, you can follow my previous videos. Let's continue with this chapter. What we have studied till now in this chapter, that we have given with some situations and we have checked that situation is always true, or that situation is sometimes true, or that situation is never true. And we'll continue with this topic. And what we see that in the next portion of the chapter, it is given that we have to check that the sum of an even number and odd number is multiple of 6. Understood? We have to check that sum of odd number plus even number is multiple of 6. So we take 2n is even number definitely, and 2n plus 1 is odd number, and 6n is always multiple of 6. Understood? So we'll add these numbers. Now see, 2n plus 1 is the result. Now these two numbers, when they are added, 2n plus 2n, this is even, and this is 1. So our result will come odd. And what in this case we have seen, all the multiple of 6 are all the multiple of 6 are even. Understood? So an even number can never be equal to odd number. So this is the case when this situation is never true. Understood? This is the situation that it is never true. We'll see what is the next situation. In the next situation, they have given us that we have to find a number when it is divided by 5, it gives exactly the remainder 3. We have to find a number when it is divided by 5, it will give exactly the number 3. Understood? So what is the number which is exactly divided by 5? 5n is the number which is exactly divided by 5. Now we want the remainder 3. We want remainder 3. So if we add 3 to this, we will get always remainder 3, and that we can check. Understood? That we can check when n is equal to 1, our result is 8. When n is equal to 2, our result is 13. And when n is equal to 3, our result is 18, and so on. Understood? So what we have concluded in this case, that n should be greater than and equal to 1. Our number should be greater than or equal to 1. We will always get the result. In this expression, we will always get the result which is remainder of 3. Now, in our book, they have given us some options. We will check each options one by one, whether they are always true, whether they are never true, or they are sometimes true. Understood? Understood? Now see, what is the first expression they have given? The first expression is 3k plus 5. Now we will check. We'll check up to one or two, 3, 4 values, and then we will decide. Now when k is equal to 1, we see 8. Understood? So it is true. When k is equal to 2, what is our result? 11. This is not true. When k is equal to 3, what is our result? 14. This is not true. When k is equal to 4, what is our result? 17. Not true. When k is equal to 5, what is our result? 20. Not true. When k is equal to 6, what is our result? 23, which is true. Means this is the case which is sometimes true and sometimes not true. Understood? What is next expression? Our next expression is 3k minus 5. Now we will see, when k is equal to 1, our result is minus 2, not true. K is equal to 1, 2, our result is 6 minus 5 is 1, not true. K is equal to 3, our result is 9 minus 5, 4, not true. K is equal to 5, or 4, 12 minus 5, 7, not true. And k is equal to 5, 15 minus 5 is 10, not true. And k is equal to 6, k is equal to 6 is what? K is equal to 6 is 18, and 18 minus 5 is 13. This is true. Understood? Now you can see that it is sometimes true. So this is also the case of sometimes. Understood? Now when k is multiple of 6, we will get our result. Understood? Means take it as a 12, and 12 3s are 36. 36 minus 5 is no, this is also, in this case also this is not true, but where, since we have seen that it is in some cases it is true, in some cases it is not true, so this is also the case of sometimes. Understood? Now we will see the third. What is third? Third is 3k upon 5, that we will see. K equal to 1 is 3 upon 5, k equal to 2 is 6 upon 5, wrong, wrong. K equal to 3 is 9 upon 5, k equal to 4 is 12 upon 5, k equal to 5 is 15 upon 5, k equal to 6. What is k equal to 6? Now see, k equal to 6 is 18 upon 5. And what is this result? When you get this, you will get the result remainder 3. You will get the remainder 3. Means here k equal to 6 is right. So this is also the case of sometimes. The next one is 5k plus 3. This is, we have already seen, 5k plus 3. This is always true. This is the case of always true. ठीक, understood. Now the second case is this one is 4, this one is 5. Second case is 5k minus 2, and this case is always true. This is also always true, that you can see if you put the value of k equal to 2, k equal to 2, you will get the result 8. K equal to 3, you will get the result 15 minus 2, 13. K equal to 4, you will get the result. What is the result? You will get 18. Now, this condition is always true when your k is greater than 1. Understood? This condition is always true when your k is greater than 1. And what was the condition for this? In this case, your k is greater than and equal to 1. Understood? Now we will see what the last expression. The last expression is 5k minus 3. 5k minus 3. We will put the values k equal to 1. That result will give us 2. Not true. K equal to 2. What is the result? 10 minus 3. 7. Not true. K equal to 3. 15 minus 3. 12. Not true. K equal to 4. Our result is 17. Not true. K equal to 5. 25 minus 3 is 22. Not true. And k equal to 6. Our result is 30 minus 3 is 27. Not true. Understood? So this is the case of never. What was our situation? Our situation was we have to find out a number when we divided it, and the remainder is 3. So in this expression we will get never this result. So this is the case of never. Now in this way we will solve the exercise which is given to us in page number 122. And what is the first question? In page number 22, what is the first question? The first question is that the sum of 4 consecutive number is 34. What are these numbers? That we have to find out. Now see, let's have a discussion about the consecutive numbers. We will revise. You already know about the consecutive numbers. Now these are our consecutive numbers: 1, 2, 3, 4, 5, and so on. Now see, if we take it as n, then what is the 2? 2 is n plus 1. Understood? What is 3? 3 is n plus 2. What is 4? N plus 3. And what is 5? N plus 4, and so on. In this way we will get the consecutive numbers. Now if we are dealing with only, suppose we are dealing with only 4 consecutive numbers. If we are dealing with only 4 consecutive numbers, it means they can be represented by like this. And this is also the true case when we are dealing with any 4 consecutive numbers like 13, 14, 15, 16. Now we will see, if this 13 is n, then this 14 is n plus 1, and this 15 is n plus 2, and this 16 is n plus 3. We see, or any 4 consecutive number can be represented by this. Understood? Also, If we here we have assumed the smallest number. Here we have assumed the smallest number. If we assume the largest number, what will be our result? If we assume the largest number, suppose we have assumed the largest number, this 4 is n, then this 3 will be n minus 1, and this 2 will be n minus 2, and this 1 will be n minus 3. And this is applicable to all. If we consider this 16 as a n, then 15 will be n minus 1, 14 will be n minus 2, and 13 will be n minus 3, and so on. If we have 12, then this will be n minus 4. Understood? Now, what was the question? That sum of 4 consecutive number is 34. So we consider the smallest consecutive number is n. So next one is n plus 1. Second number, third number is n plus 2, and fourth number is n plus 3. Understood? And what question is given, that the result, their sum is 34. Understood? So if we solve this, we'll get the result 1, 2, 3, 4. We have 4n plus 1 plus 2 plus 3, 6 equal to 34. And if we solve this, then n is equal to 34 minus 6 upon 4, that is 28 upon 4, that is 7. So our first number is 7, second number is n plus 1, 8, third number is n plus 2, 7 plus 2, 9, and fourth number is n plus 3, 7 plus 3, 10. And we can check this: 10 plus 9, 19 plus 8, 27 plus 7, 34. Understood? So this is our question number 1. Now we will see what is the question number 2. The question number 2 is, we have already discussed. Suppose P is the greatest of the 5 consecutive number. Describe the 4 numbers in terms of P. Understood? Other 4 numbers in terms of P. So what they have said, that this is solution 2. Now in this case we are taking the largest number. The largest number is P. So the other numbers will be P minus 1, P minus 2, P minus 3, P minus 4. Now these are 1, 2, 3, 4, 5. So these are the 5 numbers which can be expressed, and these are the consecutive numbers, and we have taken P as the largest number of the consecutive numbers. Understood? Now we will see question number 3. Now in question number 3, we have to say whether the given statement is always true, or sometimes true, or never true. Understood? What is our first expression? The sum of 2 even number is multiple of 3. Now see. Sum of 2 even number is multiple of 3. Let's take a random example that we'll check. Now see. 6 is even number, 12 is even number, our result is 18, and this is multiple of 3. Understood? So this is the true. Now we will take first 2 even number. First 2 even number is 2 plus 4. What is the result? 6. This is again true. Now we will see the next 4 plus 6. The result is 10. This is not true. 6 plus 8, result is 14. This is not true. Means this expression is the case of sometimes. Means sometimes it is true and sometimes it is not true. What is second question? The second is, if a number is not divisible by 18, it is also not divisible by 9. Means if a number is not divisible by 18, it is definitely not divisible by 9. We will see. Now we will check the first 5 multiple of 18 and we'll see what is the result. First 5 multiple of 18s are 18, understood. Now we will check the divisibility of these numbers by 9. What they have said, if a number is not divisible by 18, then it is also not divisible by 9. Okay, so we will see the first 5 multiple of 9. Understood? We will check first 5 multiple of 9. What are the first 5 multiple of 9? 9, 18, 27, 36, 45. Now see, this number is divisible by 18, this number is divisible by 18 and also divisible by 9, but this number is not divisible by 18, but it is divisible by 9. This number is not divisible by 18, but it is divisible by 9. It means this is the case of sometimes. Understood? This is the case of sometimes. I hope that you got the point why we have taken the multiple of 9, because it is easier to check the multiple of 9 to prove our statement. Now if two numbers are divisible by, if two numbers are not divisible by 6, then their sum is also not divisible by 6. Means what they are saying, that if two numbers are divisible by 6, not divisible by 6, then their sum is also not divisible by 6. So this is also the case of sometimes. Understood? If we take two numbers randomly, this is third. If we take two numbers randomly, say 11 plus 5. Now these two numbers are not divisible by 6. Understood? But if we have taken 11 plus 7. Now these two, okay, we'll take it 5. These two numbers are not divisible by 6. 5 and 11. And their sum is 17, which is also not divisible by 6. In this case our situation is ready, right? But if two numbers we have taken understood, if two numbers, now these number their sum is 18, this is divisible by 6, means sometimes our situation is satisfying the condition which is given to us, and sometimes it is not satisfying. Understood? So this is also the case of sometimes. The fourth one is the sum of multiple of 6. The sum of multiple of 6 and multiple of 9 is a multiple of 3. Yes, this is always true. Now sum of multiple of 6, we'll check first 3 multiple of 6. Multiple of 6, this is our question. 4. Multiple of 6 are 6, 12, 18 and so on, and multiple of 9 are 9, 18 and 27 and so on. Now add this. 6 plus 9 is what? 15. 6 plus 18 is 24. 6 plus 27 is 33. 12 plus 9 is 21. 12 plus 18 is 30. 12 plus 27 is 39, and you can say 18 plus 9 is 27, 18 plus 18 is 36, 18 plus 27 is 27, 37, 47, and that is 45. Understood? So all these numbers are multiple of 3. So this is the condition is always true. This is the condition of always true. Understood? Your fourth condition is always true. What is fifth statement? The sum of multiple of 6 and 3 is multiple of 9. We'll see. We'll take first three multiple 6, 12 and 18, and first three multiple are 3, 9, 6 and 9, and what they are saying that their sum is multiple of 9. Now 6 plus 3 is 9, 6 plus 6 is 12, 6 plus 9 is 15. Now we can see that this is a multiple of 9, but these numbers are not multiple of 9. So this is the case of sometimes. Understood? This is the case of sometimes. Now we will see question number 4. Find a few number that leave the remainder 2 when divided by 3 and the remainder 2 when divided by 4. Write the algebraic expression to describe such numbers. Means we have to find a number. When we divide that number by 3, we get the remainder 2, and when we divide that number by 4, we get the number we get the remainder 2. Understood? In both cases, we want the remainder 4. How we will find out this number? Solution 4. Now see, any number which is giving remainder 2, suppose that number is n. Suppose that number is n which is giving us remainder 2, means if we subtract n minus 2, means it is divisible by 3 according to the question. Also, if this any number which is which when we divide it by 4, that number is giving us remainder 2, means if we subtract that number remainder 2 from that number, means we will get this the result will be divisible by 4. Divisi divisible by 4. Understood? Now we want a value n minus 2 which is divisible by 3 and which is divisible by 4. Understood? Any number which is divisible by 4 and 3 is the LCM. Understood? So what is the LCM of 3 and 4? That is 12. So n minus 2 is equal to 12. Understood? N minus 2 is equal to 12, and to find the value of n is equal to 14. Understood? Now this is the number. When we divide it by 3, we will get the remainder 2. When we divide it by 4, we will get the remainder 2. So all the numbers, means all the numbers. Now this is n. If when all the numbers are multiple of 14, will give us the result. Understood? All the numbers which are multiple of 14 will give us the result. We can represent it like 1m, and your m is 1, 2, 3, or we can say that your m is greater than and equal to 1. Understood? So you get all the results. When that number is divided by 3, you will get the remainder 2. When that number is divided by 4, you will get the remainder 4. In this way you can find out that number. So we have done this exercise up to the question number 4, and rest all questions we will do in the next class. Till then, take care of yourself, and if you want to revise your first 4 chapters, please follow the previous videos and take care of yourself. Thank you very much.